Welcome to this month's Power Hour. Today, I'm going to be talking about ignition testing strategies. My name is Ryan Kooiman, Director of Training here at Scion Motor Products. And typically we're coming to you from the studio, but we had a little bit of a misfire this month. And so here I am coming from my garage at home, and we're going to be talking about this from here. So it gave me a chance to dig through my toolbox and look at some of my favorite testing tools. I've got the lab scope back there. I didn't pull it out. You're going to see a lot of lab scope usage throughout the presentation here. We're going to be current ramping some ignition coils, and it gives you a good pattern of really the entire ignition system and what each coil is doing. We're actually going to see some fuel injection or fuel injectors in there as well. But really one of my favorite tools when it comes to ignition testing is this good old ST125 spark tester. I've had one of these in all my little tool carts. So handy. Quick plug it in, clip it on, and if it can jump this gap, chances are you've got a pretty good ignition coil. There's other variations of it. I looked at some of the ones here. They've seen their use over the years. I can adjust the gap on this one. Very handy. And then I think this came with my Noid light kit. And so I don't know if I've ever used this one, but it's got a light bulb in there. It'll flash as well. Maybe one of my less preferred methods, whereas some of these are more preferred. But we're going to go through kind of all these today. We're going to talk about different types of ignition coils. A lot of today's ignition coils, we're going to see 3 and 4 wire, whether it's a newer Ford or a newer GM. These are both 3-wire applications, and you're going to see they're pretty straightforward. It's power, ground, and it's got a trigger wire that says, okay, the two of you come together, apply, and then unapply. And so it's really that simple. And so join me as we get into this, and let's talk about ignition testing strategies. So as we mentioned, ignition testing strategies is our topic here today. The purpose of the ignition system is to initiate the burning of fuel in order to produce mechanical power. The combustion process is not instantaneous, nor does it always take the same amount of time. Towards the end of the compression stroke, the spark plug will fire, and then the air-fuel mixture will ignite, generating pressure inside the cylinder. Until the piston passes top dead center, this pressure, it will produce really a negative work. There's going to be some resistance there. Once this piston passes top dead center, it's starting to travel down now, the pressure, which is still building, will produce what we're going to refer to as a positive work. So the goal of the ignition system is really to generate the maximum pressure in the cylinder between 10 and 30 degrees past top dead center. Now, the main components of a modern gasoline ignition system are the engine position sensors, engine control module, ignition coils, and the spark plugs. So let's kind of start here by talking about just base timing in the control of what goes into it. Really, the primary inputs needed for base ignition timing control are the engine speed. It's got to understand the engine stroke, which is going to be pre-programmed into the computer. Also, intake manifold pressure. Now, these will be provided by the crank position sensor, cam position sensor, and the manifold absolute pressure sensor. With a base ignition timing established, now the engine control module can fine-tune the ignition timing using intake air temperature, coolant temperature, atmospheric pressure, as well as input from knock sensors, like knock, like hearing something knocking, not newer NOx sensors. So additionally, the engine control module will modify spark timing to stabilize engine idle. But when something goes wrong with any of these inputs, many times a misfire is going to be the result of it. So it's at that point where we, the technicians, now have to dig in and do some ignition diagnosis, as our topic says here today. So let's take a look at a typical coil-on-plug ignition system. And so here we see the powertrain control module, the PCM. We see 4 different cylinders. So either it's the 4-cylinder or we're looking at just even half of a V8 engine. You'll see the crank sensor there, the cam sensor. So those are kind of both blue lines being inputs to the PCM. Then we've got the B+, fused B+, going to each ignition coil. So pretty much anytime the key's on, we're going to have power going to ignition coils. And then the PCM will trigger or turn on the ignition coil when the time is right. And it's going to be a command signal there. Or in many cases, if it's a two-wire ignition coil, it's going to be just simply a path to ground. So as we kind of explore the operation of a typical ignition coil a little bit further in this illustration, we can see the main components being the primary and secondary windings, which are wrapped around an iron core. Now the primary winding is much thicker than the secondary winding, but there's going to be significantly fewer loops of wire at that point. So we can see we've got B plus coming in the top here, and then we've got the external switch circuit there, which is going to control the ground side here. That's ultimately going to control the flow of electrons through the ignition coil. So at this point, we've got power going to it, but no ground, so there's really no work being done here. But now when that ground circuit is closed, now we've got current being supplied to the primary winding. And at this point, a magnetic field is generated around that winding. As this magnetic field continues to expand, a counter voltage will be created into the primary and oppose the flow of electrons, like a resistance. The expanding magnetic field also generates a voltage which is going to transfer over into the secondary windings. Now, due to the secondary winding having a significantly greater number of loops, the induced voltage is going to be magnified typically 200 plus times higher than that of the primary. And so at this point, the voltage won't quite be high enough yet to ionize the plug gap, but eventually it's going to collapse upon itself, and then that will jump the plug gap. So at this point in the image, we're continuing to grow that magnetic field. We're building energy. But when the current flow through the primary winding is quickly turned off, so we can see that ground circuit's been opened here, the magnetic field in that primary is going to collapse across both the primary and secondary windings. This is going to generate tens of thousands of volts into the secondary winding of the opposite polarity. Now, as the magnetic field collapses, the induced voltage will increase until it's high enough to actually ionize the spark plug gap. At this point, spark is going to develop across the plug and will continue until the magnetic field is depleted. So hopefully now you have a little better understanding of just how that ignition coil is going to actually create spark. And the ultimate goal here is to jump across that gap. And so at this point, the cycle is going to begin all over again. And so if we quickly do the math, you think about an engine turning 3,000 RPMs, that means this is occurring approximately 50 times per second. Now, I don't know about you, but that's kind of mind-boggling for me that this happens that frequently. And when you think about it in that respect, it's kind of amazing we don't have more issues with these things, right? So coil-on-plug systems, or COP, ignition systems are primarily going to be broken into two different categories here. One with a driver in the PCM and one with a driver in the coil. Now the driver and PCM coil-on-plug systems are going to require 3 circuits, and some of them are actually going to have 4. So as I go through here, I'm going to give you some examples from different manufacturers using 3 or 4 wire coils. And then the ones where there's the driver in the coil, that's going to require just 2 circuits. So here's a excuse me, example of a typical Ford driver in the PCM coil-on-plug. So here we can see the coils provided B plus source. So just kind of like my opening schematic there, we can see B plus going to it. And then the other end will be connected to a low side driver or a ground side driver in the PCM. So with this configuration, the PCM internally handles very high current. So it's turning this thing on and off. And so we've got potential for problems if anything goes back into that circuit there. And so that really leads me up to my first power tip here is if you've run into one of these things, you might be familiar with this. And these Fords are well known for burning out the driver inside the PCM as a result of a shorted ignition coil. So the worst thing a technician can do is just go ahead and install and try to program the new PCM without replacing the faulty ignition coils. At that point, you run the risk of damaging that new PCM. And so it's very important to replace really the entire set of ignition coils, just kind of a good practice here before installing the new PCM. So let's take a look at a case study here. And we've got a 2011 Ford Escape with a 3-liter V6, 171,000 miles on it. And so, yeah, it's a goodie. That probably came from Texas. You know, if it was from Michigan here, we'd see a lot more rust around the wheel wells there. But the customer's concern is that the check engine light is on and the engine is running rough. So the technician is going to plug in his scan tool. And he's going to first and foremost pull trouble codes here. And, you know, as he's pulling into the shop, he verified, yes, this thing is running really rough here. And he pulls a generic code here, P0355, ignition coil E, primary or secondary circuit fault here. And so as he looks up in service information, you can kind of see the definition there of it. And so we're typically looking for specific cylinder misfires, right? So a lot of technicians, you'd like to see a P0305 or something like that to indicate a cylinder number 5 misfire. But this is telling us that ignition coil E is at fault. So let's all play along together here. And so, you know, grab your hand or both hands here and let's count our fingers. And so as we go, A is 1, B is 2, C is 3, D is 4, E is 5. So ignition coil E would be the 5th ignition coil. But even if you look at the trouble code here, it's P0355. And so that last digit indicates that it is a circuit issue with coil number 5. So we've got a little bit of a head start here as we verify this customer concern once more. So technician fires up the vehicle, pulls up misfire data, and so we can see on the scan tool here, cylinder number 1, there's no misfires. 2, there's no misfires. 3, 4, definitely cylinder number 5, as we suspected here, has got some misfires going on. So we verified, yep, number 5. At this point, you know, we maybe pull out our spark tester and verify, is there spark coming out of the ignition coil? But one thing we need to make sure that we've got our inputs there. Do we have power going to it? And do we actually have PCM control? And that's very important to understand versus just doing swaptronics, right? Of, let's try this coil and move that one over there. So the technician, he's a lab scope guy, actually grabs his low amp current probe and a voltage probe here. And so he's going to look at the current for all 6 ignition coils and then compare that to the ground or the control side of cylinder number 5. And here's what we see. You'll notice that one of these does not look like the other. And so there's a very repeatable missing pattern here. You'll notice some smaller humps in there. Well, that's where the fuel injectors are also fed by the same fuse there. So we're seeing some of that below. And you'll notice that as that drives across, well, we're missing something here. But on channel B, where he's measuring the control side of that ignition coil, we should be seeing a ground signal. So at this point, an ignition coil would not necessarily fix this vehicle, right? The PCM is not commanding this to ground. Now, I want you to be aware, some vehicles we're actually going to have to go into the scan tool and clear trouble codes because once a code like that is set, it might disable fuel injectors, but it also might further prevent that ignition coil from firing. So there's my little tip again. Sometimes you might need to clear trouble codes before running a test like this. Technician actually did that, but no way, no how did he actually get ground going to the trigger on coil number 5. So at this point, I said, you know what? It's time to go ahead and replace the PCM. And you'll notice here, he actually recommended replacing all 6 ignition coils. And what you don't see here is all 6 spark plugs to go along with it. Why all 6? Well, they probably all had the same amount of sparks thrown through them. And if one of them shorted out, do we really want to install a new PCM? and one new ignition coil and take the risk that the other five aren't that far behind. Remember, I think this thing had like 170,000 miles or something like that. Even if it's anywhere over 100,000, one coil went bad. If something happens again to any of the other ones, that customers are going to be calling you back, accusing you of not fixing the job right the first time. So at this point, they said, you know what, go ahead and let's do it right. So hopefully you've got a little better understanding here. You see a little bit of that diagnosis or diagnostic strategy. We had the trouble code, the data backed it up. We felt like we had an ignition issue. And so now we had to verify that the work was being done and that the command was being given. Turns out the command was not being given by the PCM. And so the technician made the correct call to go ahead and replace the PCM as well as the ignition coils, because that's what really damaged the PCM in the first place. So as we look at some newer applications of Fords here, we can see that they've got a three-wire coil here. And they've been using this for probably well over a decade. Recently, I did some additional testing on Ford truck, and it definitely had the three-wire coil here. And so the three circuits, as you see there, we're going to have battery voltage, or B plus, going to it. We're going to have ground going to it. And then a circuit, which is referred to as COP X. And so in these ones, the primary driver circuit is going to be located inside each coil assembly. So the ECM applies a voltage, and now this is quite often going to be like a square wave, 4 to 5 volts here, going to that COP X circuit. The internal driver will apply the ground in B plus. So think about it. We've got what we need sitting there. And when this trigger signal comes in and goes, hey, it's like a pat on the head, turn on, and then turn off. And so when that coil is commanded that, it's going to apply the power and ground there. So no longer do we really have to worry about frying the driver circuit inside the PCM. Similarly, as we switch over to General Motors here, here's an example of a GM 4-wire coil. Same thing, they've been using these for well over a decade here. And so as we look at the four circuits going to it, we've got ignition, or B plus, going to it. We've got engine ground, and then we've got also a PCM ground, and then we've got IC, being ignition control. So primary driver circuit, again, will be located inside each coil assembly, kind of like what we saw there with that Ford. And so once again, when the ECM applies this voltage, and that's going to be a square wave, typically around 4 to 5 volts there to the coil's IC circuit, this internal driver will apply both the ground, engine ground, and B plus to the primary winding here. And so this sounds pretty familiar, right? Not a whole lot different from what we saw with Ford. Now there's that fourth wire here being a PCM ground, but if you kind of take that out of the equation, this is working identical to the Ford 3-wire coil I just shared with you. And so we're seeing that more and more common on today's modern engine applications, where it's B plus in ground, and it's got a trigger wire going to it, telling it when to apply that B plus in ground there. Now, one anomaly here is going to be Toyota, and this is kind of an older legacy one. If you're familiar with these, I think you'll appreciate these, but if you're not, well, just hear me out. So we've got the four circuits here being B plus and ground. Sounds pretty straightforward, right? IGT, which is going to be our timing signal, but there's also IGF, which is going to be a feedback or a confirmation signal here. So once again, the primary driver circuit is located inside of each coil assembly. When the PCM applies this voltage, same square wave as we've seen those other ones, which is going to be driven on the IGT circuit, the internal driver will apply ground and B plus to the primary windings. Now when the ignition control or the engine control module removes the voltage, the internal driver will turn off that circuit, and the collapsing magnetic field will induce a high voltage into the secondary winding, and spark will occur. Same as we've always had, right? At this point, the ECM applies a 5-volt signal to the IGF circuits. When the coil driver has determined that the coil has or will fire successfully, the driver will pull the IGT signal low during that period. So here we can kind of see all these put together here. And so we've got the IGT on the top and the IGF on the bottom. So it's a feedback, but that's a feedback across all of them. So in the middle, we can see the green current there. Once again, the fuel injectors and coils are probably protected by the same fuse. And so that's where we see the ignition coils as well as the fuel injectors driven here. But you see at the same time those coils are firing, there's an IGF signal being pulled low. And once again, that IGT circuit is on the top. That's one of the commands. Now, that's a command just for one of them. Now, if we went in multiple channels to each specific cylinder, we would see multiple commands. But we're simply looking at the command for one specific cylinder, whereas the current and the IGF are really being applied to all the cylinders. But because I see 4 IGF signals there and 4 current ramps, I'm pretty happy understanding this ignition system is working properly. So let's take a look at an older Scion, or maybe you'd even call this a Pontiac Vibe at some point, uh, with an unhappy engine. So 1.5 liter, close to 100,000 miles on it. Customer's concern is that the engine starts and stalls. Technician does a underhood look. Everything really looks pretty straightforward here on this VVTi application. So he's going to plug in the scan tool, and we can see we've got 3 different trouble codes here. So we've got one for ignition coil A, primary and secondary circuit, ignition coil B, and ignition coil D. So, let's take our mittens off and let's count on our fingers again. So we've got cylinder 1, cylinder 2, skip 3. That seems to be okay, but we've also got a problem with cylinder number 4. So the technician pulls up a wire schematic here, and we can see we've got our B plus, so he's going to current ramp that. We're going to monitor the ground, and then we're going to look at the IGF as well as the IGT. Now keep in mind that IGF will be showing results for all 4 cylinders. So this is what he's going to see here. We've got an IGT signal, which is great. We've got a command signal here. We've got current happening there, which is seeming okay. But look at that IGF signal. And so this should be high and only being pulled low when an ignition event is occurring there. And so this thing is not operating properly. So we've definitely got issue with the IGF circuit at this point. And so this is very common when one ignition coil goes bad, it can pull down the IGF signal for multiple ones, causing multiple cylinder issues there. And so here the technician is syncing on number 2. He's gone ahead and disconnected number 1. And I think you'll agree that this pattern looks much more as we would expect, right? We've got IGT2. We can see very repeatable there. We can see our current ramp in which the current's missing for one of them here, as well as the IGF is missing for one of them. But keep in mind, this is number 1, right? Because number 1 is missing. And so this further confirms that his sync is proper, and we're reading this the way in which we would expect. So we've definitely got a significant issue with the number 1 ignition coil. However, do we want to go ahead and go, yeah, we replaced 1 coil. Remember, there's 3 different circuit codes being set here. So it's a perfect opportunity, once again, to replace the entire set of ignition coils. Probably going to replace the spark plugs at the same time. It's got 100,000 miles on it, right? And so let's fix it. Let's get it out the door and make sure that customer doesn't come back with any more ignition coils in the near future. And for further confirmation, here we can take a look at this. We can see a much better, more respectful pattern here. And so this is exactly what we'd be looking for. So hopefully from that particular one, you got a little better feedback of the IGT and IGF feedback systems used by Toyotas. Now, as I wrap up here, our time has really flown by already. But I just want to kind of compare newer Toyotas. And so this is off a 21 Toyota Highlander. I've got a 25 sitting here in the garage, exact same application. And so if we look at it, we can see we've got B plus, we've got ground, and then we've got the IGT. And so think of that IGT as cop X on Ford, or the trigger signal, the IC control signal on the GM applications there. And so again, it's going to be a square wave applied to it that's going to trigger it, and then that's going to cause the B plus and ground to be applied, building up the current there in the primary. It's going to go into the secondary. Once it's released, it's going to jump the spark plug gap. So here's taking a look at the ignition system on this. You can kind of see the schematic there. Once again, we see our IGT as well as we see our command signal here. And if you focus on the right-hand side, I know it's hard. We got a ton of stuff going on in this image here. But the right-hand side in the red, you can kind of see the scaling for that IGT signal there. And so you'll see the flat line. But if you look above it, we're approximately 4 volts there is where our IGT signal is. And that's what I've kind of mentioned there. That's what personal experience has led me on almost all of these here, whether it be GM, Ford, Toyota, Honda, even some of the Korean manufacturers. Quite often that command signal is going to be anywhere between 4 and 5 volt signal going to it. We're not looking for a full 12 volts or something like that going to it. So don't be surprised if you run across one of those there. So hopefully you've got a little better understanding about some ignition diagnostic strategies there. If you're looking for more, go to our Standard Brand YouTube channel. We've done topics similar to this for the last couple of years. And so you can see previous power hours there and maybe pick up some additional tips there. I'm always going to encourage you to view our videos. A lot of great information here. If you want more information on this, this is a small snippet of a full one evening class put on by our great pro training instructors, a great group of professional technicians or trainers who are out there every single night sharing the knowledge. Great group of guys. Make sure to ask your local parts store when you can find the next standard class coming to your town. And if you're looking for some additional information, always go to our Standard Brand website. You can find catalog information there. You know, just this week I was at a shop and they were struggling trying to find some spark plug boots for a Ford application. So, well, let's go to the to our Standard Brand page here, and simply looked it up, gave him the part number. Now he could call the parts store and go, "Hey, this is the part number I need here." And so, great resource there. Ton of additional articles, information. If you want to sign up for the next Power Hours, you can click on training. You can find the link for that, and just a lot of great resource there. Well, all right. Well, that's kind of a wrap there. I see we've got some questions in the question box here, and so I've got Chris working behind the camera. Chris, what's a couple of your favorite questions or common themes that you think we should address here?
Yes. So one thing that came to mind for me is, why have manufacturers moved from just a 2-wire coil that we saw so often and have replaced in many times? Why have we switched from a 2-wire over to either a 3 or 4?
Yeah. So they didn't invite me to that meeting, but I'm going to give you my best theory here as a matter of fact. And so these 3-wire coils now, the actual module and all the work's being done in the coil here itself. It makes the coil a little more complex, but it lightens the load on the driver. Remember that case study in which we had the Ford Escape where it actually burned out the PCM because that was controlling the circuit. It was turning it on and off. This one here, all the work's really being done here, and you can tell by the heat sinks that this coil is built specifically to help eliminate some of those type of problems. So the PCM just has to go, hey, turn on, turn off, turn on, turn off. That's all it's got to do instead of doing actual work. So to sum it up, in my opinion, the work's been moved to the coil more so than being done inside the PCM.
Yeah, that makes great sense. We do have another question too, and something that, has brought up in many workshops and for myself as well. do all of the manufacturers use just 5 volt for a trigger, or are they using 12 volt, or, should we always look at service information, or, what's the best process for that?
Yeah, great question. In my personal experience, and I think you've seen throughout some of the examples we've used in the presentation here today, most of them have been between 4 and 5 volts. I showed that square wave on the Toyota there, but I'm never going to say always or never on this. And so, yeah, look it up in service information. But the good thing is, not many vehicles today have just one coil. And so if you're going to be scoping this thing or testing it, test the adjacent cylinders, the cylinders that are working properly. So on one of these examples, if I've got a problem with number 1 coil and I'm not sure about my trigger signal, let's look at number 2, let's look at number 3. And we even use that example of eliminating the problem one from the circuit, because that could affect the other ones as well. So unplug number 1, and now let's test the other ones and see what that looks like. Again, I'm not going to be too surprised if it's 12 volt on some of them, but personal experience, most are in that 4 to 5 volt range.
Yeah, that's kind of what I've run into too. So thank you very much for the clarity, and I like the idea of comparing one to another, and we've on good maybe somewhere else, so why don't we use that?
Perfect.
Just a fun last wrap-up question. What all you have in the background?
A mess is what I have in the background here. So yeah, over my shoulder here is my 60 Chevy C10. Been a year-long project. Kind of brought it back from the dead, and that's been fun. And then this one here is actually my son's 03 S10 with a twin turbo LS application. So you can see the fender exit exhaust here. So that's where you don't want to be standing. But if we had more time, that'd be a fun ignition case study to look at. The coils are relocated on the frame on these things, and people do all kinds of wacky stuff with that stuff to make them work. But back to the basics, it's still the same. It's got the power ground and the trigger wire going to it, and it's just pretty cool about that. So, well, we're kind of out of time here, so thanks everybody for tuning in. Hope to see you from the studio next time. But feel free to double check our YouTube channel if you've missed. This is kind of our 3rd or 4th ignition one we've done. And so feel free to go back through the archives and look at some of the ones there and see if there's something we may have missed. But otherwise, we'll see you at the next one, or we'll see you in class one of these nights.